it's completely independent of the actual system. So they're depending on which precautions are taken to prevent changes to that. It may not actually be the same as the time t when it was actually made. Yeah. I mean, there's always cases of, the OJ claim of, oh, I didn't put that there, the police put it there to frame me, or these types of defenses that claim that, this was added there after it was acquired. Can you prove that this was the same as the actual system? So this gets into kind of reconstructing and showing that, at time t, this is the actual same as the system. So the analysis part, basically the current tools are basically very good at importing this low-level disk image. They can then abstract it. They know about various partition systems and file systems and application types like, Word or HTML or PDF and email systems. And they can basically define all these higher and higher level abstractions on the system to allow you to view the data at these various levels. In doing so, they're not very good at identifying what's possible. So basically, they don't go through the formal analysis of saying, at this given time, what programs existed to make this abstraction possible. They basically assume that, or they basically show you the abstraction, whether the system supported it or not. So it's kind of the more efficient method of not having to analyze every program in a system and basically just showing you the data, whether it actually could have been viewed by the user or not. There's basic reconstruction support, again, for file recovery, as I mentioned before. And the reason that this is kind of the only one is that abstract events are very complicated and difficult to understand. And they can change with every version of every operating system and program. It's actually very hard to actually determine and enumerate all of the various events that could occur to reconstruct states based on these things. So this actually occurs very minimally, or supported very minimally in programs. And so what's missing from most of the tools is basically a formal support for capabilities of what are the capabilities of the storage system and event system at both the primitive and abstract levels. The duration of the system, when did the system first exist to its current state? It's usually not crucial to an investigation beyond, did the system exist at that time frame, which is why it doesn't really exist. And again, said before, layers of abstraction, which is one of the impossible things that will never really be supported. So it's not really it's not really a major thing missing from the current tools. So the summary of this work is basically that we define the model to represent the computer's history, because the existing notions of the process models and various descriptions and approaches were kind of relatively ad hoc and organized based on a specific type of investigation or a specific investigator's experiences. In this general model, we can define categories based on these variables and show some kind of completeness with them. And we can show the categories with some kind of completeness to find all the variables and show that this actually can be used to define investigation with some kind of formality. And we were a minute over, I guess. So sorry for the technical confusion there with the slides.
So where do you think, what's happening next in the next 5 years or so in digital forensics? You need to formalize techniques? Do you need to have new tools?
Well, this is, so the formality kind of stuff is kind of this debate in terms of, and I didn't get in this part of this talk either, but one of the motivations for us is actually the legal system kind of likes the formality of things and likes some kind of formal theory with it, basically for challenges. And it's kind of this unknown question in terms of what formality digital evidence will be held to in comparison to the other physical sciences. So there's what's called these Daubert guidelines, which are used to enter scientific evidence into court. And there's both sides that argue they don't apply or they do apply. And if they do apply, then it means they have to have formal testing and formal published procedures and kind of more of this formal process of defining how they fit into these categories. Excuse me. Bless you. But it's debate. But it's not clear whether they actually need to fit into that category. And it can be argued that digital systems are harder to apply this category or this rigorousness because they change so much. The possible events that can occur for each program change. For each release of the program, the attacker can come in and change them all, and it kind of remains to be seen with what rigor that the whole process can be held to, because it's so dynamic and changing. So this kind of like paves one path that's used, but it's debatable to what degree it'll be held to, I guess.
Any other questions? Well, thank you.